Hello, hi, and welcome to my presentation, to my team's presentation on text summarization using pre-trained large language models. My name is Godswill, and I'll be talking us through the work that we've done and demonstrating the the code implementation and how the models work and displaying results. So yes, the agenda for this presentation is to talk us through the objective of the task, the datasets that we used, and the size of the datasets that the subset of datasets that we used to fine tune the model, the models that we used, and sort of compare their results after the experiments. So the objective of our task, in a nutshell, was just to take two of the state-of-the-art models, Pegasus and BART, and fine tune both of them individually on two separate datasets, the Samsung dataset and the site TLDR dataset, which are which have both have an article or text and a corresponding summary as a label. In other words, we have a labeled dataset with summaries in each of them. So we wanted to just fine tune a mod these models on 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 each dataset um, individually. And the goal is to compare the performance of the models on the datasets using the rogue metric. So, like I said earlier, the dataset that we've used is the Samsung dataset and the SciTLDR dataset. Briefly, the Samsung dataset consists of dialogues paired with summaries, suitable for conversational summarization tasks. So, it's a dataset that was annotated by humans, um, of to replicate the to replicate how people will chat on Messenger app. So it involves two people talking, and then a label and the corresponding label of the summary of the conversation or the dialogue. So we decided to use. Before I go, okay, you know what? Okay, yeah, I'll talk about. We decided to use 148 samples for training, 9 samples for validation and testing. I'll briefly talk about why we use the subset of the dataset and not the entire dataset. But before I do that, the CiteLDR dataset consists of scientific articles along with their summaries as well. So this one's is scientific articles um, that are too long, um, and so humans also annotated these datasets with summaries, corresponding summaries. Um, we used 100 samples and 31 samples for validation and testing. The reason why we've used a subset of the dataset and cut it very short is the because of computation limitations, because of we didn't have computational resources to use the entire data set, which would have been amazing to work with, to see the full potentials of these large language models when you fine tune them for a specific task, such as text summarization. Moving on, so the two models that we chose to compare to use to to, to fine tune on for text summarization is Pegasus and BART. Pegasus was developed by Google for abstract. Well, it wasn't really for abstractive text summarization, but it was for language modeling. Um, it uses an encoder-decoder architecture with self-attention mechanisms. BART, on the other hand, was introduced by the researchers at Facebook, and it's used for sequence-to-sequence tasks too. Language is also used for language modeling. These are very large language models. Um, they all have a lot of parameters, and they're great for numerical multiple tasks such as text summarization, question and answering, neuromachine neuromachine translation, and so on. So when we conducted the experiment and fine-tuned the dataset, the models on the dataset. Um, let's start with the performance that these models obtained when they were both fine-tuned on the Samsung dataset. So surprisingly, the Pegasus and BART model actually had exactly the same um, performance measures with respect to the rogue metric. Um, and so um, now this is interesting because one can assume that because of the dataset size was the same, and again the dataset, in my opinion, was not sufficient for fine tuning to achieve significant performance. Um, a good rogue metric. But however, what was impressive was seeing the training loss this low and the validation loss this low as well for both of them. Moving on to the site LDR dataset, we couldn't obtain Pegasus rogue metric um, because we run out of memory almost every time. So you can imagine using just so little little data to do this, we still run out of memory. So imagine if we ended up using all of the data, which is about 140,000 samples inside the data set. But the BART performance was actually the best. BART outperformed the Pegasus and BART model when it was fine tuned on Samsung dataset, achieving a 6.5% and 7.9% precision for Rogue One, and it had the same measure across all Rogue variants, Rogue One, Rogue Two, Rogue L, and the training and validation loss was also pretty low. So without further ado, I do want to conclude by saying that both language models show they show they're promising for text summarization. And at the end of the day, this study just highlights the effectiveness of transformer-based models for text summarization tasks and opens avenues for future research. Thank you. But before I go, I want to quickly do a demo of the code. So I'm just quickly going to import my dependencies. Here I'm at my Colab workspace. These are the dependencies that I used. This is the library that obviously was used. We have transformers from Hugging Face. We import this auto tokenizer and training arguments, and this is what you use to load the data set. So I'm going to use so here I have BART Samsung, what I've written to train the model, but I'm going to just select one of them to show working. I think I'm going to go with the BART site LDR. So I'm going to load the model. Okay. Load the data set. So we're loading data set. So here, I've already run this before. So you can see what I did here was that I just collected one test sample and its corresponding label, and I tried to generate what the language model before fine-tuning would do, and it generated the summary. FearNet, based on this article, it generated the summary. FearNet is a generative model that does not store previous examples, making it more memory efficient. FearNet uses brain-inspired dual memory system in which new memories are consolidated. However, this was the human annotated summary, the correct summary of the label. Apparently, the human summary is even longer. Anyways, moving on. I'm going to preprocess our create or prepare our data set, if you will, for training. That's what I'm doing here. With all this, with this function here, basically. I don't want to waste too much time. I'm gonna try to fine tune the model again. The 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 data set we used is very little. It's a very small subset of the entire data set. Um, the size of the samples is 100, and yeah. So moving on to train the data set, I don't know if I want to wait for it to train. Okay, it looks like it's going quick because I've run out of time. Um, yeah, so we can evaluate the performance, and then I just wrote a function here to evaluate the performance. This is where I obtain my real metric scores, and you can see here, this was the values that we got. So thank you very much. Thank you for thank you for giving me your time, and this is the end of the presentation.